with this, again, the book gives you formulas for sine, cosine, and tangent. I am not requiring the tangent formula. So, if you look at the book, ignore the tangent formula. We are going to use tangent, but you do not need the formula. I'm going to show you how we use tangent without the formula. You don't need the formula. I will show you how we're using it without the formula. Trust me. It's okay. Trust me. I'm a doctor. I'm not a doctor, but I'm just a master. Okay. So let's start with sine, because sine's the easy one. That's the double angle. So what we do is, if we have a 2 inside of the sine, we can take it and turn it into a single angle without the 2. Now, we have the same thing with cosine. There's 3 versions of this formula, though. However, this formula comes from, the versions of this formula come from the Pythagorean. So, there's one version of the formula. To get the other versions of the formula, you just substitute in the Pythagorean. So, if I would take the sine squared and replace the sine squared with 1 minus cosine squared, I would get the second form of this, which is 2 cosine squared x minus 1. The other way is if you take and you replace, this has a minus, right? So whenever I have this times a minus, this would become a minus 1 and this would become a plus cosine. Yeah. So then the other way is if you take cosine squared x and you replace it with 1 minus sine squared. So then your minus sine squareds would group together and you'd end up with 1 minus 2 sine squared. So those are your 3 versions of the formula. You kind of use whichever one is most convenient. You could always use this form and then, switch to these others, but it's pretty convenient to kind of realize you have all 3, or, at the beginning of your quiz or test, take this version and change it into the other so you have all the versions sitting there. All right. My issue with this section is on your tests and your quizzes, pretty much everything I'm going to ask you to do is verifying and solving. However, this section doesn't have anything for verifying. So I put a verifying problem on your notes, but just realize for your homework you're not going to have any verifying, but on the quiz and tests, I'm going to ask you to verify. All right, so I want to verify this. Now, I have a 3x in here. What do I do with that? I was wondering where the music was coming from. That's my music. Huh? Yeah, I have a light switch that turns it on and off. No, it's coming from my computer. Okay, so I don't have anything for a 3x. So how can I get it so I can use my formulas? Okay, that's exactly right. 3x is the same thing as 2x plus x. Okay, and now I have formulas to separate that, correct? We just did that on Monday. Oh, this over here? No, I don't want to deal with that. Because it's easy to get this out of here. It's hard to put it back in. Why did I do this? Because I have no way of getting a 3 out of there. However, if I split a 3 into a 2 plus 1, from Monday I have my sum formulas. So now I can take the addition out. We're using my sum formula. So according to my sum formula, this is sine 2x cosine x plus sine x cosine 2x. So you may start having problems where you have to use multiple formulas from everything we've had. Okay, so now I have my sine 2x, so I can use my formula up here because my goal is to get all the numbers out of the signs because over here I don't have any numbers inside. So sine 2x is 2 sine x cosine x, and then I have another cosine x plus sine x. Let's see, cosine x. Now, everything over here is sines, correct? So which formula up here do I want to use? The 1 minus 2 sine squared, because I want to get rid of as many of those cosines as I can. All right, so let's see, 2 sine x cosine squared x plus sine x minus 2 sine cube x. Okay, so I'm getting there. Problem is I still have a cosine in there. How do I get rid of that cosine? Pythagorean. So I can get rid of this cosine the same way as I got rid of a cosine up here, because Pythagorean says cosine squared of x is 1 minus sine squared. Okay, then I have a 2 sine x plus a sine x, so that's 3 sine x. And I have a minus 2 sine cubed and a minus 2 sine cubed, so that's minus 4 sine cubed x, which is the same as the other side is what I was looking for. Yep. So that used some formulas from every one of our sections. from Monday. That was our sum formula. Sine, because I had a sine here. So I did the, yep. And then I used the formulas from today to get rid of the 2's. Then I did some simplifying because I had a mess. No, I used the 1 minus 2 sine squared because on my right-hand side, everything was sines, so I didn't want to create more cosines. I just wanted sines, so that's why I used the 1 minus 2 sine squared. That's why it's helpful to know all of them, so you can aim for whichever one you want. Because I could have used the top one. I could have used the top one. I could have used cosine squared x minus sine squared x, and then I could have taken that first cosine and I could have used Pythagorean and changed it. It would have just created another step. Now, this is a difficult verify. I'm giving you that. I wanted to show you a difficult verify because a lot of the verifies that we have been doing are very simple. And they're like change everything into sine and cosine and everything cancels out nicely. So I wanted to give you an example of a difficult one where you have to do multiple steps and use multiple formulas. All right. So, now, there are no verifies in your homework. Again, I just wanted to give you an example. In your homework, you're going to have some solving. So you have some problems that look like this. In fact, at this point, I was rushing, so I literally pulled this one from your book. All right, I need to solve this. In order to solve these problems, first of all, you have to have the same trig functions, and you have to have the same things on the inside. I cannot solve a problem that has a 2x and an x. It's like having an x and a y. So that's why we have to have the double angle formulas. So for this, I need to get this 2x into an x. Whenever I go to change this, which formula do I want to use? Nope. Well, okay, yes, I want to use the cosine one, but whenever I change the cosine has 3 versions. Which one do I want to use? Look at what else is in my problem. No. Nope. I want to use the third one. Yeah, I want to use this one. Why do I want to use that one? Well, all of them just have an x. All 3 of them just have an x. I have cosine squared x minus sine squared x. I have 2 cosine squared x minus 1. I have 1 minus 2 sine squared x. Why would I pick that one? I picked this one because I'm going to have to do some sort of factoring. I need to have both of them being sines. If I would pick something with a cosine, I couldn't do anything with it still. So I need to have the same trig functions in order to factor. No, I couldn't take a sine out unless they all had sine in them. And if I use something like this, I have no place else to go with that. And see if I chose this one, I still have nowhere else to go with that. Because I can't take out a sign unless everything has a sign. So this is the best choice. Now if I rearrange it a little bit, and I'm a little bit of a factor Nazi. I don't like negatives at the front, so I'm going to divide everything by -1. Okay, so I go to factor two things that multiply to a -2 and add to a -1. So that would be -2 and +1. Nope. You have to remember them. That was agreed upon by all the trig teachers a long time ago. That we would make you memorize all the formulas. So it's happening in all the trig classes. You're not special. All right, so places on the unit circle where sine of x equals -1/2. You guys see where you can do this in your head yet again? No. Why not? Okay, and 1? 1's easy. Come on. When does sine equal 1? Huh? Square your unit triangle. What?
No. Why can't we have a unit squared?
You can, but what fun is that? Every side is 1. And I guess, the middle isn't 1. The middle is radical 2, but... Okay. We're going to go back and have some of these. Some of these will actually be on the test. So you have some other kind of problems besides just factoring and verifying. Or not factoring, but solving and verifying. They won't be like this. This is kind of an introduction. They'll be more like example 4, but we're going to go through this first. Okay, before I do anything, I always need to know the hypotenuse, so I might as well start off by finding the hypotenuse. So what's the hypotenuse? And you do that just by using Pythagorean. Okay, now, I have no idea what theta is. No clue. So, without knowing what theta is, I cannot just calculate 2 theta. It's not like I can just take 3 and 7 times 2. That doesn't work. Because 7 actually decreases, and 3 increases, but they do not increase by 2. Plus, and well, your hypotenuse would actually stay the same. But what we need to do with this, since we can't actually calculate what 2 theta is, and it's going to ask you for exact values, so you know you could use your inverse trig and go and do it that way, but you're going to get decimal answers. They want exact answers. So the way we do this is we use our formula. So according to our formula, that's what sine 2 theta equals, correct? So that means I take 2 times sine of theta. Well, what's sine of theta? Opposite of our hypotenuse. So 3 over square root of 58 times cosine of theta. Well, cosine of theta is adjacent over hypotenuse. I can't stop writing. I already said it. What? Yeah, that's the sine 2 theta one. That was the first one I gave you. Okay, so then all I have to do is multiply it together. I'd end up with 42 over 58, which reduces down to 21 over 29. You with sine 2 theta, you don't have a choice. There's only one choice. Sine 2 theta is 2 sine theta cosine theta. There is no other option. With cosine, you have an option. It really doesn't matter with this. You can choose whichever one you want. It's going to come out to be the same.
How did you get that formula?
I gave him to, you weren't here for it. I gave it to him. Yeah, that's a good one. Okay, so for cosine 2 theta, doesn't matter. Since we haven't used it at all, I'll just use this formula. Okay, well, I already figured out what these were. Cosine theta is 7 over square root of 58 squared minus 3 over square root of 58 squared. So that's 49 over 58 minus 9 over 58. Which is 20 over 29. There you go. C's easy. Okay, tangent is sine over cosine, right? Take your sine 2 theta answer divided by your cosine 2 theta answer. Use what you know about trig to do this. tangent is just sine divided by cosine. So I just take my answer for my sine divided by my answer for my cosine. So that's 21 over 29 times 29 over 20, which is 21 over 20. Okay, so what's D going to be?
Oh,
29 over almost
20.
20. We don't have any formulas for secant. We don't need them. Secant is 1 over cosine. So if I know what cosine 2 theta is, I just flip that over to get secant. Because remember, this is just 1 over cosine. So really, we can get by with just knowing the sine and cosine formulas. I'm not going to give you anything as far as verifying or solving where you need to use the tangent formulas, because I'm not requiring you to memorize those. Yeah, those formulas. Okay. One more. So this is what that is going to look like for your test. Instead of giving you the triangle, we want to do more than just a triangle. We want to use it anywhere in the unit circle. So here's cosine of x equals negative 1/3. So that means I have a triangle someplace. Well, this tells me that on my unit circle, my triangle is actually in the third quadrant. It's in between pi and 3 pi over 2. So my line is over here. So here's my triangle. Yep, but I want my triangle to be wherever I want it to be, not just a normal triangle. So, according to this, the hypotenuse is 3. Since it's cosine, this is my x value, so my x value is negative 1. Since I'm in the third quadrant, is my y value going to be positive or negative? Negative. So, use Pythagorean, what is that value going to be? Square root of 8, which is, simplify that, you guys can do that. 2 radical 2. So that's the way it's going to be given to you on test. But then you go through the work just the same. So I did my coordinate plane. It tells me my angle is in between pi and 3 pi over 2. So 3 pi 3 pi over 2. So I just drew a line in there, so I made sure I was in the right spot. Cosine is the x value over the hypotenuse, or the radius. So I put the 3 on the diagonal line. I put the negative 1 on the x value. And then I use Pythagorean to find my y value.
So that's gonna be in the circle, but like.
Yeah, I just didn't. It's not actually the unit circle, because the unit circle goes around at 1. And it's not the unit circle because this goes out 3.
But it like the.
But yes, same idea. Okay, so sine of 2x. Just pretty much do these problems the exact same way. Okay, so sine is going to be negative 2 radical 2 over 3 times negative 1/3. So that's going to be 4 radical 2 over 9. Cosine 2x. You could do cosine 2x without even having the formula or having the triangle, because they told you what cosine of x is. So cosine of 2x, I could use this formula so I can make sure that if I messed up my triangle, I could still get the right answer. So that's 2/9 minus 1. So that's going to be negative 7/9.